Okay.
Okay, you can go live.
Okay, thank you, Amanda. Hello, everyone. Welcome to Mathematics Leaks with Tapio Nyamunda here. I'm going to take you through grade 10 maths mix. So what I have prepared for you today, guys, is a bunch of questions. We're going to look at measurement. We're going to look at measurement of time. We're going to look at measurement of weight. We're going to look at measurement of mass. And we are also going to look at calculations that can determine the length of a substance given a few dimensions. So I have here a question from 2017. So the question here this shows a kitchen scale that is measuring these fruits in grams. So we have here a pear, a peach, and a plum, and we have 394 grams. That is the mass of these three fruits that we have here. That is the mass of the three fruits that we have. So it says here the mass of the pear is 128 grams. The mass of the plum is half mass of the pear. And we are also given a note here says 1 kg equals 1000 grams. Is supposed to know. Okay, so let's move on to our first question. I have it says answer the questions that follow. Convert the total mass of the fruit into kgs. We want to convert this total mass that we have been given. We want to convert it to grams. So let's see how we can do that. Okay, so the total mass of the fruits that we have been given here, we can see that it is 394 grams. 394 grams. This is the mass of the fruit. So we need to convert these to grams. So what do we know? We can use simple proportion, guys. If you're familiar with simple proportion. Simple proportion makes use of the information that you already know about a situation. So we have a situation here. So what do we know about this situation? We know that 1,000 grams is equal to 1 kg. So what do we need to do? We need to convert these to grams. So what do? We say 394 grams is equal to a question mark. So you ask yourself, is it going to be more than 1 kg or is it going to be less than 1 kg? So as you can see, 1,000 grams is more than 394 grams. So meaning we are going to have less here. We are going to have less kg. So if we have less kg, what does that mean? So there is a rule that if it is less, we say a smaller number, which is 394 grams, over a bigger number, which is 1,000. multiplied by quantity. Our quantity is always on the right side. So how do we do the multiplication? Grams and grams, they cancel out. What we have 1,000 into that, 1,000 into that, we have 0.394. But remember, guys, we have no units here because we have cancelled out the units that we had previously. So how do? We say, how do we tackle this? We have 0.94 times 1 kg. So this will give us 0.394 kg. So this is how you get to the answer. This is how you get to the answer. Yeah. Okay. Let me just show you again another situation that we have not been given. A situation where we can have, after the question mark here, we are having a situation where we are having more in place of having less. How do we tackle that? Okay, let me show you. Okay, let's take the example. We are being asked to find what is 2,780 grams. What is this in kgs? The question asks you, what is the value of 2,780 kgs in grams? How would you tackle a question like that? This is how you do it, guys. Just as we have been doing previously, we do the same thing here. We have, what do we know about kgs and grams? What is the relationship that we know about these two quantities? We know that 1,000 grams, again, is equal to 1 kg. We now need to figure out what is 2,780 grams in kg. So we just have 2,780, and we have our question mark. Is it going to be less than 1 kg, or is it going to be more than 1 kg? So the obvious answer there is more. We are actually going to have more kg. So I have more here. So if I have more, the situation is different from what we have been doing previously, guys, because here we have a situation where we have more. The rule says if it is more, we say a bigger number over a smaller number. So this is the bigger number over the smaller number multiplied by the quantity. Quantity is always on the right side. This is always the quantity, the one above question mark, above the more. Okay, like we did previously, grams and grams, they cancel out. 1,000 into 1,000, we have 1. 1,000 into 2,700, we have 2.78. 0 if you want. Okay, we have 2.780 multiplied by 1 kg. This will give you 2.780 kgs. Don't forget the unit, guys. Since we have cancelled out this unit, hence the final answer will have the units of the quantity. Whatever the units of the quantity, whatever the situation you are provided with, so this is how you do it. Okay? I hope you have understood that. Okay, let's move on to the next question that follows. Okay, so we are done with this question. It says convert the total mass of the fruit into kgs. That is what we did here. So we find that the total mass of the fruits in the basket is 0.394 kg. Okay, let's move on to the second question, guys. The second question says, the pear is removed from the kitchen scale. Write down the new reading in grams shown on the kitchen scale. Okay, so this one is asking us to find out the mass of the other two foods that will be left on the kitchen scale. Okay, so how do we do that? So we know the mass of the three, the mass of the three in grams is given as 394 grams. And we are told that the pear was removed from this. And the pear is actually having a mass of 128 grams. So we need to subtract that from 308. So this is just a matter of subtraction. So we have 128 grams. We want to do subtraction. Okay, so since we are subtracting grams, obviously we are supposed to get grams. Yeah. Okay. So we have grams there. Then we have 14 minus 8, which is 266. That is the value we have here. 266. That is the mass of the plum and the peach. The mass of the plum and the peach. So this one was a simple question, guys, just a matter of subtraction there. Just a matter of subtraction there. Okay, let's move on to question 3.3. Question 3.3 says, show how the mass of 202 grams for the peach was calculated. Okay, so we now have the mass. Here we have the mass of the plum. So this here, guys, is the mass of the plum. Here we have plum and peach. These two values we have there. We have the mass of the plum and the peach. But we also have information, we are given some information about the mass of the plum. So the mass of the plum, we have been told that the mass of the plum is half the mass of the pear. So the mass of the plum, let's say plum is equal to 128 grams over 2. This is the information we are provided. We are told that the mass of the plum is actually half that will be here. So we have 128 divided by 2, which will give us 64. So the mass of the plum is 64, right? And they are asking us, what is the mass of the peach? If I get that correct, let me just check again if I'm answering the correct thing here. Okay. Okay, so we are to show how the mass of 202 for the peach was calculated. So we want the mass of the peach. We already have the mass of the plum. So we know that this value we have here is representing the mass of both the plum and the peach. So we want to figure out how we can calculate. Okay, so pitch mass is equal to 266 grams minus 54 266 minus 64. Okay, so 6 minus 2, we have 2, 6 minus 6, we have 0, 2 minus 0, we have 2. So here we have the required answer of 202. So that is the mass of the pitch. So these are the steps we have to follow, guys. As you can see, these are easy steps to follow, simple and straightforward. Okay. Let's move on, guys, to the next question. Okay, so the next question says, question 3.4. Okay, so this is a 2017 question paper, guys. If you want to revisit the questions that I'm doing now, you need to visit our website. I will show you at the end of the lesson where you can get the paper. Okay, so let's look at this question. It says, determine the probability of randomly selecting a banana from fruit placed on the kitchen scape. Determine the probability of selecting a banana from the fruit placed on the kitchen scape. As you can see, guys, as you can see, I see no bananas there. I see no bananas. So the probability of selecting a banana is 0. That's what he does. Probability of selecting a banana, let's say the probability of selecting a banana is actually 0. Because there is no way we are going to get a banana when we don't have bananas. So it was just a tricky question to get you to have 2 marks. These are free 2 marks. They are donated to you guys if you are the one who got this step. Okay, so you get these 3 marks for nothing. Okay, let's move on to question number 3.5. Question number 3.5 says, write down the simplified ratio of the total mass of the fruit to the total mass of the peel. Write down the simplified ratio of the total mass of the fruit to the total mass of the peel. So we have the total mass of the fruit. What is the total mass of the fruit? The total mass of the fruit, guys, is 394 grams. H2. Total mass of the peel. The total mass of the peel, we have it here. Okay, so the total mass of the peel, we have already been told that it was the total mass of the peel, we have already been told this is the total mass of the peel. So how do we do that? We have 394 H2 12 grams. Again, guys, this is a ratio. A ratio is just a way of representing fraction. A fraction is a ratio. If we write, for example, if we write 1/4, it's just the same as 1/4. So this is just a way of representing numbers. So we can get rid of this since it is a ratio, and we can get rid of this. And it simplifies to 394 H2 128. Here. Okay, so we need to find common factors between these 2 numbers. we need to find common factors between these two numbers. Okay? How can we do that? We have to think of a way of finding numbers that get into this number and this number without leaving a remainder. So yeah, you can do trial and error, guys, to figure out if you get to the answer. Okay, but if you're using your calculator, you can just write. You can just do this. You can have 394 divided by 128. Okay. Then I need to convert this number to a decimal number, to a fraction. So this is the fraction that I will get. I hope you can see that this is the fraction that I will get. So I got 197 S2 So this is the simplest ratio that you can get. This is the simplest ratio that you can get. You could have said 2 divided by this. You divide 2 into this number, you divide 2 into this number. That's how you get to this number. So this is the simplest fraction that you can get from that number. Okay? Let's move on, guys. So you get your 2 marks simply by doing that. Okay. I have another question for you guys. Okay, so I have here a table shows the motorcycle lane speed record from 1930 to 2010. So we are going to analyze these records. We have riders. We have the year, the year the record was achieved. Then we have the record itself, the speed that was attained by different riders, and we have also again the year here. So this is continuing, guys. We have 3 rows of data, and this is continuing. We have 3 variables. We have year, speed, rider. These are the 3 variables, and the span of the years is from 1930 to 2010. And these are the records for different riders of motorcycle. These are motorcyclists. Okay. You have a question. Answer the following questions. Use the table above to answer the following questions. So question number 4.1 is asking us to determine the difference between the highest and the lowest lane speed records that were set between 1950 and 2000. So we have 1950 and 2000. We want to determine the difference between the highest and lowest speed that we achieved during this time. Okay, let's go back to our table, guys. So where are we starting from? Okay, so we are starting from 1950. This is 1950. Where is 1950? Okay, so all these records we're not going to include that. We are going to start from here up to here. This is the record we are going to look at. Okay, so let's analyze these records one by one, guys. Let's analyze the records one by one to see how we can tackle this question. Okay, so we have 1950. The record attained by Rubens Haas was 180. So as you can see, let's see here. Okay, so the highest value I can see from this record, guys, is 322.5. That is the maximum value I can get. So I can write max is equal to 322.15. Okay, 222.15. That is the highest value I got there. Okay, then the smallest value from these records, I can see the smallest value was attained in 1951. The value was, so I can write minimum here is okay. So these are the values that we have. So the question is asking us to find the difference between the maximum attained and the minimum attained. Okay, so again, guys, it's just a matter of subtraction. So we have 322.5 subtract 180.29. Okay, so here we have 15 minus 9, that will give us 6 here. Then you carry 1 there. 11 minus 3, we have 9. We have we have a 3 here. So we have 8. Okay. Then 2 minus 1, we have a 1. 12 minus 8, we have a 4 here. 3 minus 2, we have 1. Okay. So the difference is actually 141.86. Okay, let's see if we have been given units in this question so that we can include them in our calculation. Let's see the units that we're given. Okay, so it seems like we are not given units in this question, so we just leave our answer as it is. We're not given units, we're just given it is speed. So speed can be measured in different units. It can be measured in meters per second, kilometers per second, as you know, guys. So we are not going to include any units. We are not going to assume any units here. So we just leave our answer as it is. Okay, so we have determined the difference between the highest and the lowest land speed record that we have taken. So you get your 3 marks from that. So how are 3 marks distributed? So you get your 3 marks from first here, then you have your another mark here, then you have another mark for the final answer. That's how the marks are distributed. Okay, let's move on to question number 2. Determine the number of rides that set new land records from 1930 to 2010. So the question is, determine the number of rides that set new records from 1930 to 2010. Okay, so I just need to write my year here so that when I look at the records, I won't be confused as to what I'm looking for. Okay, so we are switching from 1930 here to 2010. 1930 to 2010. So we are starting from here. So it says determine the number of rides that set new lane speed record. So we are looking for the time that the previous record was broken. So we have this as the first one. So you can use tallies, guys, if you are afraid to make a mistake. You can use tallies. Okay, so I have the first one. As you can see, in 1930, a record of 150.65. As you can see, this is the highest since 1930. Okay, so we can say this is the first one. We have a record that was achieved in 1930 of 137.23. Okay, then another record in 1930 was achieved again. Okay, then 1930 by Joseph S. Wright, again another record. That is another record. Then here we have 1951. A new record is set. This is a new record again. Okay. Then we have here 1952. 1952. Okay. Then we have here, what do we have? We have another one. Let me just count them. We have 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 18, 14, 15, 16, 17, 18, 19, 20, 21. Oh, so we have, so basically what I'm seeing from this question, guys, since he says determine the number of rides that set new lane speed records from 1930 to 2000, all of these are new lane records. Why? Because each year, as you can see, each year, if we were to look at in 1930, we have each preceding year having a number that is bigger than the previous one. So that automatically means it's a world record. It's a record, sorry. It's a lane speed record. Because if you have a value that is greater than the previous value, automatically that value becomes a record. So that is basically what you wanted me to add here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times 2, that's 24 plus 1, that's 25. So it will be 24 value to you. Okay, let's look at question number 3, guys. Question number 3 says, identify the 2 years during which the lane speed record remained unbroken for the longest time, and also state the number of years the record remained unbroken. Okay, there is identify the 2 years during which the lane speed record remained unbroken for the longest time. Also state the number of years the record remained unbroken. Okay, so let's look at the question again. Okay. 2014. 2024. 245. Again, what do I put? We have 302. 18.6. Okay. So as you can see from these values here, this is the same person having to broke his own record. And also we have the same person here having the same record as previous. So you could count the number of years from which from 1930 to 1937 to find the difference between these 2 years. So I can have 19, the last year was 1936, subtract 1930. So this is it. So during this time, Ernst J. Hing was the world record holder for 6 years. For 6 years, Roger was the world record holder. So if I subtract these values here, if I say 8 minus 5, I'll get 3. So this is even smaller than what equals. So we're looking for a period of 6 years. So, okay. So it says, name the rider that held the lane speed record the most number of times, and also state how many times the rider held the record. So this was the question you answered. So the rider was Ernst J. Hing. That was the name of the rider. So he held the record for 6 years. So let's just look if we can find another one. No, there's no one else. As you can see here, Don Desco only held the record for 3 years. Ernst J. Hing held the record for 6 consecutive years. And he also held the record for the 7th time here. As you can see, held the record. Okay, let's look at the question again. Identify 2 years during which name the rider that held the lane speed record the most number of times, and also state how many times the rider held. Okay, so we are saying we have 6 plus 1. So he held the record for an extra year. That is in 1937. We have an extra. Okay, let's see if we can find another Ernst. Oh, sorry. I have to say plus 1 plus 2. So we have 8. We have the record for 8 years. Because we have 1 here, 2, 3, 4, 5, 6. Okay, so I was actually right the first time. So we actually have the record for 1, 2, 3, 4. We have the record here for 4 years, 5, 6. So you have the record for 6 years. Sorry guys. For 6 years. Okay. Let's look at the question that follows. Okay, it says determine the probability as a percentage of randomly selecting lane speed record in table that was set during the 21st century. Okay, want to determine the probability. Okay, so we have discovered that we have 25 values. So our n is equal to 25. That is our n. What is 21st century? How many values do we have that we obtained in the 21st century? We have 2006 here. So we have 1, 2, 3, 4, 5. Okay. So how do we find the probability of an event type? probability of an event A, for example, it is given by number of A times over the total outcome. So when I say NA, I mean number of times A is occurring. So my A here, let me define the event. A is equal to 21st century. 21st century record. That is my A. A is 21st century record, and our total is 25. The number of outcomes, the number of possible outcomes, the number of events in our probability set. Okay, I know some of these things we haven't done, guys, but we just for us to, it's a good thing to just read ahead. Okay, so we have number of times the event A is occurring. How many times is the event A occurring? So from our question there, from our table, we can see that A is 21st century record. So we have 1, 2, 3, 4, 5. 5 21st century records. So how do we write that? We have 5 21st century records. So our NA is equal to 5. And our total probability, N we can say, let's note it as NT. NT is equal to 25. What is the probability of event A happening? Is equal to 5 over 25, which is equal to 1 over 5. So this is the probability of having probability of randomly selecting an event that is from the 20%. So the probability of just selecting any single event that is from the 20% from this record is equal to 25. So this is how you find the answer. We have NA being probability of event A happening. A is equal to 5 over 25. You simplify it to 1 over 25. Okay. Okay, let's move on, guys. Let's move on to this one. Okay, so we are done with this question. Okay, so I actually have another one for you. The Jumanda decided to investigate the temperature changes in Upington by using historical data of the record temperatures. The historical records of extreme maximum and minimum temperatures, as well as the minimum and maximum, and the mean maximum and minimum temperatures in degrees Celsius of Upington in the table below. Okay, so here we have a month of the year. Then here we have the extremes, the extreme maximum and the extreme minimum. And here we have the mean maximum and the mean minimum. Okay, so we have the values here. Hottest temperatures we actually expect to be the lowest temperatures we actually expect the same thing here. Okay, so let's look at the question. So it says, according to Apple Watch, the highest temperature for October was recorded on Tuesday, 27 October 2015. And when the temperature reached 119.1 Fahrenheit. Convert this temperature to degrees Celsius. Round off to 1 decimal place using
5 minutes
formula.
before the end of the session.
Okay, thank you. Okay, so we want to make degrees Celsius here the subject of the formula. Okay, so this is actually a invitation to us to look at, because it involves a concept that I like so much. Concept of change of formula. Subject of formula. Okay, so we have the Fahrenheit here, and you have degrees. Okay, let me show you what I'm doing. Okay, so we have Fahrenheit in degrees Celsius. Times 9/5 plus 32. Okay. Okay, and we are given the value that we want to change. So we want to find out what is 119.1 Fahrenheit in degrees Celsius if you are to use this formula we have been provided with. Okay, let's see how we can do that. Okay, so we have at this value, we want to convert it to a degree Celsius. So what we do is, as you can see, this is in Fahrenheit. So we substitute here. So we have 119.1 degrees Fahrenheit being equal to degrees Celsius 82. Okay, so the thing here, guys, is we want to leave this guy. We want to leave this guy on his own. We want to divorce him. We can say that. Okay, so we want to leave this guy on his own. So the thing that you need to know, guys, is the opposite of operation. You are familiar with the opposite of addition is subtraction, the opposition of multiplication is division. So that is why we make use of. But we are only considering what is happening to this guy here. Okay, so before we talk about this guy on his own, we can see there is a multiplication going on here. So we can take these two guys as if they are the same thing, so that we can get rid of this part. So what is happening to this part here? We are having addition. So we have taken this to be a single thing, and we said, what is happening to these guys here? They are being added to 32. So the opposite of addition is subtraction. So I will say subtract 32 this side, then I will say subtract 32 this side. Okay? So when I say C times 9/5 plus 32 minus 32, this guy will disappear here. So what I will be left with is 119.1 minus 32. This will give me 87.1 being equal to C times 5 over. So this guy is equal to 0. We have reduced that guy to 0. Okay. Again, I ask myself the same thing. I want now to separate these guys from each other. I can take these guys as one thing, right? Or I can do it slowly. Let me just do it slowly, guys, so that you get what is happening. Okay, so I see C is multiplying 9, and this 5 is dividing C. So between these two operations, between multiplication and division, you can choose either way you want to do it. You can either start with division or you can start with multiplication, whatever suits you best. Okay. So I want to start with 5, which is dividing. So 5 is dividing C. So the opposite of dividing C is multiplying. So what is happening to C? C is being divided by 5. The opposite of dividing by 5 is multiplying by 5. So I will multiply by 5, then I will multiply by 5. Okay, what you do to this side, you have to do the other side, guys. Okay, you have to be fair, in other words. Okay, so when I say C times 9 over 5 times 5, these guys will cancel out, will cancel each other out. So I have 87.1 multiplied by 5. I'll get 435.5 being equal to C 9. Okay? Again, I ask myself, what is happening to C? Because the objective, guys, is to leave out C on his own. Remember, we want to divorce. Okay, so we will divide everything. As you can see, C is being multiplied by 9. So the opposite of multiplying by 9 is dividing by 9. So what I will do is I'll say over 9 here, over 9 here. So when I say this and that, will cancel out. So I'm now left with 435.5 divided by 9. Okay, what do I have there? C being equal to 871 over 8. I always advise you guys to leave. If you cannot, you round it off, but I would prefer you leave it in that form. Okay, guys, so this is what I had for you today. I also have a question I would want you to do when you relax back at home. Okay, let me just look for it here. Okay, so I have a question here. I would want you to look at, guys, while chilling at home. You can take a look at these questions. So this is what we will start with on Monday. So we'll start with these questions and see if we are able to give a simplified form of the ratio of the distance of AD to distance CB. It's just the same as we have been doing. We are able to calculate the perimeter of A, B, C, D. So look at that. We are also given clues on how to tackle that. Okay, so we are also going to write down. So just relax and go and look at this question, guys. It's really simple. So if you have any trouble, you can just message us and we'll get back to you. Okay, thank you. I hope you learned something today. See you on Monday, guys. Have a good weekend. Bye.